Hello friends, today we are going to start the rotational motion part of the chapter Rotational Dynamics. तुम्ही supposing हा दरवाजा आहे. Now when the door, this is the hinge and when the door is opened, so this is the rotational motion. Now, the handle of the door is here, and when we held the handle and we open the door, we close the door. Have you thought upon that? Why the handle is not in the midway of the door? इथे handle का नहीं है? So what is the reason that handle इथेच दिलेलं आहे आणि इथे मध्ये दिलेलं नाही किंवा या पॉइंटवर दिलेलं नाही आहे? ह्या सगळ्या गोष्टी आपण या चॅप्टरमध्ये डिस्कस करणार आहे. याचा आणि जेव्हा तुम्ही त्याचा अनुभव घ्या की जेव्हा आपण इथे हँडल घेऊन आपण असा डोअर ओपन करतो तेव्हा फोर्स आपल्याला अप्लाय करायला लागतो, तो फोर्स हा कमी असतो. आपण जेव्हा इथून जेव्हा फोर्स या दाराला ढकलतो, इथून जेव्हा दाराला ढकलतो तेव्हा फोर्स जास्त अप्लाय करायला लागतो आणि इथून जेव्हा आपण दाराला ढकलतो तेव्हा अजून जास्त फोर्स अप्लाय करायला लागतो. सो व्हॉट इज द रिझन व्हाय to open a single drawer? Why the forces applied are different or they increase in magnitude as we go towards the hinge? So we are all going to discuss today and in this chapter the reasons that this force, now this force is not only when we are opening or closing the door, the force which we apply not only depends upon how much force we apply, but it also depends upon the distance from the hinge. So the more the distance from the hinge, the less force is required, the less energy is required, the less torque is required. So in this chapter we are going to discuss about the rotational motion of a rigid body. Now what is a rigid body? Now supposing I take this, if I apply force to this body, if I apply force, it should not change its dimensions. मी ह्याच्यावर बाहेरून खूप अगदी जोराचा फोर्स नाही, पण साधारण फोर्स मी ह्याच्यावर जर अप्लाय केला आणि जर ह्याचे डायमेन्शन्स जसे होते तसेच राहिले, then it is a rigid body. मी जर एखादा खूप मोठा एखादा दगड घेऊन ह्याच्यावर ठोकला, then it is going to break, then it is तसा फोर्स नाही. A force, when I apply a force and if the dimensions of the body do not change, then this is a rigid body for that particular force. Supposing this is a rigid body, I am applying force to it, so the dimensions are not changing, they are remaining the same. So for this particular force, this is a rigid body. Now in this chapter we are going to discuss the expression for the rotational kinetic energy. Now consider this is a rigid body. This is a rigid body and this rigid body is rotating about this particular axis of rotation by angular velocity. The angular velocity, that is the angle traversed in 1 second, is omega. So angular velocity is omega. So this rigid body is rotating about this axis in this way. So angular velocity is omega. Now we say that let there be n number of particles in the rigid body. So the first particle is m1. I have drawn the figure here. The first particle is m1, the second particle is m2, the third particle is m3, dot up to mn. So there are m1, m2, m3 dot dot up to mn particles in the rigid body. This is the 2D figure which I have drawn on the board, and this is the 3D figure. So there are the n particles in the rigid body, and every particle. So this is first particle m1. The distance from the axis of rotation is r1. The distance of the second particle from the axis of rotation is r2. Similarly, for all the particles I have drawn here, r1, r2, r3 dot 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 up to rn. So these are the respective distances from the axis of rotation, of the rigid body. Now, when this rigid body will start rotating about this particular axis of rotation with angular velocity omega, every particle of the rigid body will move in circles. Now this is a particle m1. So this m1 will move in circular motion. The second particle is m2. The m2 particle will also move in circular motion when the rigid body is rotating. This irregular shaped rigid body, मी मुद्दामच तो shape irregular घेतलेला आहे. So it is rotating in every particle. So every particle m1, m2, m3 dot dot up to mn, all the particles move in the circular motion. All the particles of the rigid body move in the circular motion. Now, we know that every particle moves with same angular velocity, that is omega. The angular speed is same, that is omega. But all the particles are not at the same distance from the axis of rotation. सगळे particles वेगवेगळ्या distance वर आहेत. Hence, their velocity. Now I am considering the first particle. Supposing I am considering this particle m1. So what is the velocity of particle m1? That is v1 is equal to r1 into omega. This is the velocity of the first particle. Then m2. What is the velocity of the particle m2? That is v2 is equal to r2 into omega. Up till. So we are considering for all the particles, and we are considering the nth particle, the last particle. So the velocity of the particle mn is vn is equal to rn into omega. So all these particles are moving with different velocities because they are at a different distances from the axis of rotation. Some particles are very near, some particles are far. Some particles are very near, some particles are far. So at a different distance from the axis of rotation. Hence their velocities v1, v2, v3 dot dot up to vn are all different. Now I want to find the translational kinetic energy of each particle. That is, each particle is rotating, right? So what is the kinetic energy of the translational motion? That is, each particle. It is a circular motion. Circular motion is a special case of linear motion. So that particle for that particular very small instant is moving in a straight line. So the translational kinetic energy of m1, m2 dot dot up to mn, we are going to calculate it now. So kinetic energy Ke1 of the first particle of mass m1 is half of m1 v1 square. Then that is equal to half of, we put the value of v1, that is r1 omega. So half of m1 r1 omega square, that is half of m1 r1 square omega square. Now next, the kinetic energy of the second particle of mass m2 is half of m2 v2 square. Putting the value of v2, we get half of m2 r2 omega square, that is half of m2 r2 square omega. Similarly, we are putting the values for all the particles of all the masses, and the last particle mn has kinetic energy Ken is half of mn vn square, that is half of mn rn omega square, that is half of mn Rn square omega square. So these are the kinetic energies of the particles which are moving, right? But the motion is the circular motion. So, and the body is rotating about this particular axis. So now we are going to calculate the kinetic energy of all the particles. Hence, so these are the kinetic energy of each particle which is moving in circular motion. So the kinetic energy, so the rotational kinetic energy. Now because though the particle are moving at that particular point in the straight line, but still after that they are changing their direction, and hence the motion of each particle m1, m2 dot dot up to mn is a rotational motion. So we are going to find the rotational kinetic energy. So kinetic energy of the rotational motion or the rotational kinetic energy is Ke1 plus Ke2 dot dot up to Kn. So kinetic energy or the rotational kinetic energy is half of m1 r1 square omega square plus half of m2 r2 square omega square dot dot up to half of mn rn square omega square. Now we know that the term half is in every particular term. So we take half common, and also omega square is also in every particular term of the kinetic energy from first particle to the last particle. So we take omega square common. So we write half of m1 r1 square plus m2 r2 square plus m3 r3 square dot dot up to mn rn square omega square. Now let m1 r1 square plus m2 r2 square dot dot as m1 r1 square plus m2 r2 square dot dot up to mn rn square, which is equal to summation of I equal to 1 to n mi ri square. This is equal to I. So how can I write this expression? So from 1 and 2 we can write here the kinetic energy is half of I omega square. So the kinetic energy of the rotational motion of this body, of this rigid body, when this rigid body is rotating in this way, so the kinetic energy of the rotational motion of the rigid body is half I omega square. So, but what is I? This I we have considered m1 r1 square plus m2 r2 square dot dot up to mn rn square. So this I has some particular significance, and it is called as the rotational inertia of the body or the moment of inertia of